Hi everybody. So today we're going to focus on our review of inverses. So this is actually in your summer packet. So if you find the inverse questions, I think it's like the second or third page. I can't actually remember. So just true and false. So A, every function has an inverse. That is false. If it is not one-to-one, it cannot, why am I not writing anything? If it is not one-to-one, it cannot have an inverse. So that's false. If the composition of f and g equals x for all x in the domain of g, then f is the inverse of g. That's not necessarily true because you need to be able to go backwards. So that's also false. It's kind of telling once you read part C, question C, then you're like, oh wait, no, that's going to be your true one. So C is true. The composition is x for all x in the domain of g, and then when you go backwards, that's also true for everything in f. So it needs to go both ways. Sine is 1-to-1. That is false. Remember, for 1-to-1, it's got to cross the horizontal line test, and that is definitely not passing. 1 over x plus 2 to the third is 1-to-1. That is true. Because I think it's because it's to the third. Usually the ones that are odd, it works. The ones that are even does not. All right, so composition, the definition. So this is an illustration. It's in your textbook. The idea here is the range of G and the domain of F have to overlap. Otherwise, this just doesn't work. You have to be able to, the domain and the range have to overlap. Otherwise, you're not going to be able to do it. You're going to have no solutions for certain problems. We're not going to like seriously get into this, but I just wanted to kind of have show you that general picture. Again, the range of G and the domain of F have to overlap. Otherwise, you can't have a composition. All right, so these are in your textbook. I love these. I don't know why. We're going to do a lot of stuff with these tables. We do a lot with tables. So getting used to this is important. So remember, we start with the one on the right, and then we do the one on the left. So A, G of 1 is 0, and then we use that and plug that into F. F of 0 is -1. B, G of -1 is 0. F of 0, is that the same problem? Oh no, it just happens to work out like that. All right, pause the video, do C through F. F of -1 is -3. G of -3 is 8. So we're just looking at the table, right? Go to -3, G is 8. F of 1 is 3. G of 3 is 8. A, B, C, D, E. G of -2. So we go to 2 and we go down. It's 3. And then we're doing G again. G of 3 is 8. And then for F, F of -1 is -3. F of -3 is -7. That's it. All right, pause the video, do this one now. All right, so we got G of 1. G of 1 is 0. F of 0 is 5. G of 2 to start is -3. Take that -3, plug that into F, and we get 11. F of 2 is 1. G of 1 is 0. F of 3, go to 3, is -1. G of -1, -1, go to G, get 0. G of 1, go to 1, G is 0. G of 0 is 1. F of 3 is -1. F of -1 is 7. Questions? You can't ask me questions. Email me if you have questions. All right, same exact problem, but now we're using a graph. Remember I said in class the other day that there are 4 ways to represent a function: the equation, a table, a graph, and a description. So you spent a lot of Algebra 2 doing the equations. Now we're looking at the tables and the graphs. Review of it. All right, so f of -1, f is the blue one. Gotta remember that, f is blue. -1 is 1, so g of 1 is 4. That's the answer. F of 6, let's see, f of 6 is 2, g of 2 is 2. G of 6, that's the red one, 5, f of 5 is 1. G of 4 is 2, f of 2 is -2. F of 1, that's the blue one again, right? Yeah. -1, g of -1 is 3. F of 5 is 1, right there. G of 1 is 4. G of 7 is 5. F of 5 is 1. G of 2 is 2. F of 2 is -2. That's it. All right, so this one, it's really just, we're talking about a description. We're not graphing anything. So looking at the pictures, actually, you're not even using the pictures here. The graph of f is shown below. Describe the transformation that would take place for each graph. It's going to be the same. So +3, what does +3 do to a graph? It shifts it up 3. When the inside has a +2, it's shifted left 2. When you have a negative in front, it goes upside down, right? So reflects across the x-axis. This one has the +1 on the inside, so that's left 1. -2, down 2. This one, it is, what's the word? Not shrink. I guess it's shrinking. So all the y values are cut in half. So like for E, for instance, this would go from 2 to 1. So it would look like just all the y values. That is a terrible picture that I just drew there. So all the y values, so it's shrunk, I guess. F of -x, that's a reflection, reflect across the y-axis, right? Because all your positive x's are going to the negative side. So like this is a cosine in 48, it wouldn't do anything because it's an odd function. So if you flipped it around the y-axis, nothing would happen. And then 2x, this is instead of, did I write shrunk or shrink? This one was shrink the y values. Shrink y values. So for this one, when the inside is multiplied by 2, you're kind of stretching it. It gets stretched left to right. Okay, 1 to 1, so that was in the do now. A function that is increasing on an interval is 1 to 1 on that interval. A function that is decreasing on an interval is a one-to-one function on I. So this is just the notation, showing what the notation for inverse is. Be careful, there's a difference between inverse and then like x to the -1 equaling 1 over x. And we deal with both of those in this class, so make sure you know the difference and can recognize the difference. X is a variable, f is the name of a function. All right, true or false? So pause the video and do these. If every vertical line intersects the graph of a function at no more than 1 point, then f is 1-to-1. That is false. That is the definition of a function. If the domain of a 1-to-1 function is 4 to infinity, the range of its inverse is 4 to infinity. Remember, x's and y's reverse, so the domain becomes the range. If f and g are inverses, the domain of f is the same as the domain of g. That is false. The domain and range will be the same. If f and g are inverse functions, their graphs are symmetric with the line x equals y. That is true. Well, wait. Symmetric. Their graphs are... Oh, yeah, that's true. One way to find a function, an inverse, is to reflect a graph over the line y equals x. If f and g are inverse functions, then the composition equals f times g. That is false. Major false. If a function is 1-to-1, where x is the domain, 1-to-1, where x is the domain of f. No, x would be the in the range of f. I'm going to go with false. I might have gotten that wrong. I'll check it later. Given a collection of points, explain how you determine if it represents a 1-to-1 function. So that's where you would check all the y values. Y values don't repeat. Given the graph, explain how. So that would be the horizontal line test. All right, last page, find the inverse. Check the result, find the domain and range. Okay, so to find your inverse, you flip your x and y. Remember, this is your y. So then we're going to reverse our x and our y. Cube both sides. So f minus 1 of x is x cubed minus 10. Since this is a cubic, the domain and range are all real numbers, so that's boring. All right, 35 is a little harder. So I have x equals 2y plus 3 over y plus 2. This is a good one just for our algebra skills. So what I do is I cross multiply. So I do xy plus 2x equals 2y plus 3. Now remember, we're trying to solve for y, so we're going to get all the y's on one side. So this guy's going to move over here, and the 2x is going to move over here. So I have xy minus 2y equals 3 minus 2x. So I just subtracted in one shot. Now I have two y's in the problem. I need to go from 2 y's down to 1 y. I do that by factoring the y out. Now I'm down to 1 y value. So y equals 3 minus 2x over x minus 2. And that's your inverse. So for the original function f, our domain was all real numbers except x equals -2. And our range, remember we divide our x's, all real numbers except y equals 2. Now, if you look at the inverse function down here, it's kind of nice. You can see that our domain, all real numbers except x equals 2, all real numbers. So the domain and the range match up. You just have to switch your x and your y. And then if you divide your x's, negative 2x divided by x, you get negative 2. Right, so if you're looking here to find the range, just like we divided before, negative 2x divided by x is negative 2, which is what we had. So that did work out. All right, so no homework. I just want you to review for the quiz on domain, range, inverses, composition, and trig. All right? Let me know if you have any questions. I'll see you guys later. Bye.